Welcome back to Black Box Ops, the channel that pries open the classified projects and uncovers the hidden stories behind the gear that gives our elite warriors the edge. We see the dramatic footage, the night raids, the hostage rescues, the precision strikes. We marvel at the capability, the technology, the almost science fiction-like tools wielded by America's special forces. We assume these tools are born in gleaming, multi-billion-dollar R&D facilities, the product of committees, contracts, and years of meticulous top-down design. Sometimes that's true, but sometimes the most revolutionary piece of kit, the device that fundamentally changes how operators fight and survive, doesn't come from the top. It comes from the bottom. It comes from a lone wolf, a tinkerer, maybe even a perceived failure, who sees a problem no one else does and builds a solution so simple, so unorthodox, that the entire system dismisses it out of hand. Tonight, I'm telling you my story. I wasn't a special forces operator. I was a civilian engineer, buried deep in the bowels of Natick labs, supposed to be working on improving helmet padding or refining camouflage patterns. But I saw a gap. A deadly gap in how our most elite units navigated and communicated in the most dangerous, GPS-denied environments on Earth. My solution wasn't sleek. It wasn't high-tech in the conventional sense. It was built with off-the-shelf parts, looked like something from a high school science fair, and violated about 50 mil-spec standards. They didn't just reject it. They laughed at it. They called my prototype stupid, a gimmick, a waste of taxpayer money. But that stupid prototype, it held the key. It was the seed that grew into a technology that is now utterly fundamental to how U.S. Special Forces operate, survive, and dominate in the shadows. This is how one inventor's stupid prototype changed the way Special Forces operate. Before we infiltrate this story, if you believe that innovation often comes from the most unexpected places and that the status quo needs to be challenged, then I need you to secure our comms channel. First, hit that subscribe button and activate the notification bell. It's your primary way to support the mission here. Second, give this video a like. It signals to the algorithms that these stories need to be declassified. And finally, drop a comment below. Let us know what country and city you're monitoring this transmission from. Our global intelligence network is our greatest asset. All right, let's power up the prototype. My name is Dr. Eris Thorne. Yes, doctor. It was both a blessing and a curse back then, in the late 1990s. A blessing because it got me in the door at Natick, the Army's primary research and development center for soldier systems. A curse because, in the deeply hierarchical, rank-conscious world of military R&D, being a civilian PhD barely 30 years old meant I was automatically suspect. I wasn't one of them. I hadn't worn the uniform. I didn't understand the real world, or so they constantly implied. My official project was mundane. Advanced infantry helmet systems, basically trying to make helmets lighter while stopping bigger bullets, and maybe integrating some rudimentary heads-up display concepts that were still mostly science fiction. It was important work, I suppose, but my mind was elsewhere. It was stuck on a problem that wasn't officially mine to solve, a problem I kept hearing about in hushed tones from the few Special Forces NCOs who rotated through Natick as user liaisons. The problem was navigation and communication in denied environments. Think deep tunnels, dense urban canyons, subterranean bunkers, thick, triple canopy jungle, places where GPS signals simply couldn't penetrate and where even standard military radios struggled, the signals bouncing erratically or being absorbed entirely. Our Tier 1 units, the Deltas and the SEALs, were being sent into these black holes with equipment that was often little better than a magnetic compass, a paper map, and maybe a line-of-sight radio that was useless the moment you turned a corner underground. They were operating blind and deaf in the most dangerous places on Earth. Men were getting lost. Units were getting separated. Missions were being compromised, sometimes fatally, because of a fundamental lack of reliable situational awareness and communication in these specific, critical environments. The official solution, being worked on by massive teams with huge budgets at places like DARPA and MIT Lincoln Labs, involved complex, exotic technologies micro-inertial navigation units, IMUs, that drifted wildly over time, ultra-wideband radios that were power-hungry and easily detectable, even bizarre concepts involving mapping magnetic field anomalies or using cosmic rays. These were multi-million-dollar, multi-year projects, aiming for a perfect, elegant, high-tech solution that was always 5 years away. It struck me as absurd. We were trying to solve a caveman problem, how not to get lost in the dark, with spaceship technology. What if the solution wasn't high-tech? What if it was low-tech, but used in a smart way? My background wasn't in RF engineering or advanced physics. It was in sensor fusion and robotics. I thought about how simple robots, even insects, navigate complex environments. They don't rely on a single perfect sensor. They use multiple imperfect sensors and fuse the data. They use relative positioning. They leave trails. They build maps as they go. What if we could do that for soldiers? Forget GPS. Forget satellites. What if each operator carried a small device that could talk to other nearby devices, measuring the distance and bearing between them using a simple, low-power radio signal? What if, as a team moved through a tunnel or building, they could leave behind tiny, cheap, disposable beacons, like digital breadcrumbs, that the main devices could use as reference points? You wouldn't have absolute position like GPS gives you, but you'd have relative position. Every operator would know exactly where every other operator was, relative to themselves and the deployed beacons. You could build a 3D map of the environment in real time as you explored it. And the same low-power radio link used for ranging could also carry small bursts of data, text messages, sensor readings, biometric data. Secure, short-range, difficult-to-detect communication, plus real-time indoor navigation and mapping. It seemed elegant, simple, almost too simple. I started sketching. Not on a CAD system, but on napkins, on the back of requisition forms, late at night in my cluttered little lab cubicle. The core idea was a small, wearable device, let's call it the node, and even smaller, cheaper, throwable beacons. The node would use a simple time-of-flight radio ranging technique. It sends out a ping, the other nodes and beacons receive it and ping back, and by measuring the precise time difference, you calculate the distance. Do that with multiple devices, triangulate, and you get relative positions. Add a basic magnetometer, compass, and altimeter, pressure sensor for height, to each node, and you get orientation and elevation. The beacons wouldn't need much, just a simple radio transceiver and a battery, maybe the size of a Zippo lighter. You could toss them into rooms as you cleared them, drop them at junctions in a tunnel. They'd form an ad hoc, self-organizing network, a temporary digital infrastructure created on the fly. I knew the radio part was tricky. It had to be low power to avoid detection and conserve battery, but strong enough to penetrate walls or work around corners. It couldn't interfere with existing comms gear. I settled on using ultra-wideband, UWB pulses, very short, very low-power bursts of radio energy spread over a huge frequency range. UWB was mostly theoretical back then, used in some experimental ground-penetrating radars. It was inherently difficult to detect, had decent material penetration, and crucially, its short pulse duration was perfect for precise time-of-flight ranging. I needed to build a prototype. I had virtually no budget. My official project funding was strictly for helmets. So I became a scavenger. I sweet-talked technicians in the radio lab into giving me obsolete RF components. I pulled microcontrollers from discarded test equipment. I bought cheap digital compass modules and barometric pressure sensors from an electronics hobbyist catalog. My first prototype node wasn't wearable. It was a shoebox-sized monstrosity of breadboards, wires, salvaged chips, and a tiny LCD screen cannibalized from a broken scientific calculator, all powered by a stack of D-cell batteries. The beacons were even cruder, just a tiny RF transceiver board hot-glued to a 9-volt battery, stuffed into a plastic project box. It looked utterly ridiculous, like something a kid would build for a science fair project about how radios work. It was held together with electrical tape and hope, but it worked. In my lab, late one night, I placed 3 beacons in the corners of the room. I walked around with my shoebox node, and on the tiny LCD screen, a crude dot matrix map appeared, showing my position relative to the beacons, updating in real time as I moved. I could even send a simple text message, test, from the node, and have it appear on a second prototype node connected via cable. It was rough. It was ugly. It drifted. The ranging accuracy was maybe plus as 1 meter, but it was proof. Proof of concept. Relative navigation and data. No GPS required. I was ecstatic. I had cracked it. This was the solution to the GPS-denied nightmare. I scheduled a presentation, not for the high-level DARPA types, but for my immediate superiors at Natick, Colonel Peterson, the head of the Soldier Systems Directorate, and his chief civilian engineer, Mr. Abernathy. These were solid, experienced men, but deeply conventional. Their world was helmets, body armor, boots. Radios were someone else's department. Complex navigation systems were definitely someone else's department. I lugged my shoebox, my beacons, and a tangle of wires into the sterile, brightly lit conference room. They looked unimpressed. "All right, Thorne," Colonel Peterson said, glancing at his watch. He had a golf game scheduled. "What miracle have you cooked up for us today? A self-polishing boot, perhaps?" I tried to explain the concept, the nodes, the beacons, the UWB ranging, the relative mapping, the data capability. Their eyes glazed over. They didn't get it. They couldn't see past the ugly box, the messy wires, the cheap plastic beacons. "So," Mr. Abernathy interrupted, peering at my shoebox with disdain, "let me get this straight. You've built a walkie-talkie. That tells you how far away your other walkie-talkies are. Using, what was it? Ultra-wideband. Isn't that radar thing they're trying to use to find landmines?" "Well, yes, sir, but it's much lower power and it's for navigation and data." "Navigation?" Colonel Peterson scoffed. "Son, we have navigation. It's called GPS. It's accurate to 5 meters, anywhere on Earth. Why on God's green earth would we need this thing? That only tells you where your buddies are, and only works if you scatter these little pucks everywhere." "Sir," I pleaded, "GPS doesn't work underground. It doesn't work reliably in dense urban canyons. It doesn't work in heavy jamming. This does. This is for those environments. For the tunnels in Afghanistan. For the bunkers. For science fiction scenarios, Dr. Thorne." Abernathy cut in smoothly. "Look, it's a clever gimmick, a nice little academic exercise. But it's not practical. It's not mil-spec. How long do those batteries last? What's the data rate? What about encryption? What about interference with SYNCGARs or have-quick radios? What about the logistics of carrying hundreds of these little beacons?" He waved a dismissive hand at my setup. "It's stupid, Thorne, frankly. It's an elegant solution in search of a problem we're already solving with multi-billion-dollar programs. It's not robust. It's not secure. It's just not the way we do things." Colonel Peterson stood up, signaling the end of the meeting. "Abernathy's right, son. Stick to helmets. That's your lane. This radio stuff, leave it to the professionals at CCOM. Thanks for your time." They walked out, leaving me alone in the conference room with my stupid prototype. The rejection wasn't just professional, it was personal. They hadn't just dismissed the technology, they had dismissed me, the civilian, the PhD, the guy who didn't understand the real world. I stood there, the silence ringing in my ears, staring at the little green dot blinking on my screen, representing me. I had shown them the future, and they had called it stupid. The silence in that conference room wasn't just the absence of sound. It was the crushing weight of institutional inertia, of dogma solidified into rank and regulation. Colonel Peterson and Mr. Abernathy hadn't just rejected my prototype. They had rejected the possibility that a better way existed outside their carefully managed programs of record. They had called my shoebox full of wires and hope stupid. And in that single dismissive word, I saw the chasm, the vast, dangerous disconnect between the clean, orderly world of requirements, documents, and budget cycles, and the dirty, chaotic, lethal reality faced by the operators I was trying to help. My face burned. Not with embarrassment, but with a sudden, clarifying surge of anger. They were wrong. Not just technically wrong about the potential of UWB ranging or ad hoc networking. They were morally wrong. They were prioritizing bureaucratic neatness over battlefield necessity. They were sacrificing potential lives on the altar of mil-spec compliance and established procedure. They couldn't see the forest for the trees, blinded by the glare of their multi-billion-dollar GPS constellations, unable or unwilling to imagine a scenario where that perfect, elegant system simply failed. But I could, because I had listened. I had listened to the frustrated whispers of the SFNCOs, men who lived in that world of shadows and tunnels, men whose reality wasn't captured in the glossy PowerPoint slides presented by defense contractors. They didn't need a system that was perfect in 5 years. They needed something that worked, however imperfectly, right now. I packed up my stupid prototype, the components suddenly feeling heavier, burdened now not just by hope, but by defiance. They had ordered me to stick to helmets. They had drawn my lane, my box. Fine. If they wouldn't let me work on the solution in the light, I would work on it in the shadows. I wouldn't just hide the hardware. I would become a ghost within their own system. The first step was survival. I meticulously disassembled the prototypes, returning the recognizable, serial-numbered components, the Syncars RF module, the Bradley computer casing, back to the supply system, creating a digital paper trail of compliance. But the heart of the system, my custom microcontroller boards flashed with the rudimentary mesh networking code, the jury-rigged UWB transceivers built from salvaged radar components, the cheap but functional sensor modules. These vanished. They became unserviceable test items, damaged components pending disposal, digital phantoms lost in the labyrinthine inventory system. They ended up in an old Pelican case, hidden under a pile of discarded Kevlar helmet shells in the back of my already cluttered lab cubicle. My official work on advanced infantry helmet systems became my cover. I became the model junior engineer, diligent, quiet, focused. I produced reports on ballistic trauma, on suspension system ergonomics, on non-ballistic impact absorption. I attended the endless mind-numbing meetings. I nodded politely when Mr. Abernathy pontificated about the future of integrated optical sights, which were, of course, 5 years away. I played the game. But every night, after the labs officially closed, after the security guards made their rounds, my real work began. My cubicle, lit only by the glow of my monitor and a cheap desk lamp, became the secret forge of my rejected future. I couldn't build more hardware. Not yet. It was too risky. But I could refine the brain, the software, the algorithms. That was the real magic anyway. The hardware was just a vessel. I taught myself advanced coding techniques, diving into assembly language to wring every last cycle of processing power out of the salvaged microcontrollers. I optimized my ranging algorithms, developing adaptive filters to reject noise and multipath echoes, the very ghosts that plagued high-power radars, but which my low-power, short-pulse system could potentially distinguish. I worked on the mapping logic, figuring out how to represent a complex, multi-level 3D environment based purely on the relative positions of nodes and beacons, how to stitch together a coherent picture from a swarm of distributed sensors. I devoured academic papers on simultaneous localization and mapping, SLAM, a field still in its infancy, mostly confined to robotics labs. I was trying to build a system that could allow a team of operators, moving blind through a dark tunnel, to collaboratively build a map of their surroundings in real time, purely based on their own movements and the signals bouncing between them. It was ridiculously ambitious, pushing the limits of what was possible with the pathetic processing power I had access to. And I tackled the security issue head-on. Abernathy's dismissal of my system as insecure had stung because it was true. My simple XOR cipher was a joke, but military-grade encryption was locked away, far beyond my reach. So, I improvised. I couldn't build unbreakable encryption, but maybe I could make the signal itself disappear. I refined the UWB pulse modulation, experimenting with pseudo-random noise sequences, spreading the signal's already faint energy over an even wider band, making it statistically almost indistinguishable from background noise. Low probability of intercept, LPI. Low probability of detection, LPD. It wasn't encryption, but it was stealth. A signal you couldn't even find was harder to jam or exploit than one you could see but couldn't decode. All this work was theoretical, confined to simulations running on my aging desktop computer, fueled by lukewarm coffee and the constant low-level fear of discovery. I needed data. I needed hardware. I needed help. My break came, not from a sympathetic engineer, but from the most unlikely of sources. Master Sergeant Reyes, one of the rotating SF-NCO liaisons. Reyes was a Green Beret, a communications specialist, a man who had spent more time setting up antennas in hostile jungles than I had spent in classrooms. He was quiet, deeply skeptical of academics like me, but he possessed a brutal, pragmatic intelligence forged in the real world. He was assigned, mostly as a box-checking exercise, to provide user feedback on my helmet project. One afternoon, he was in my cubicle, patiently enduring my presentation on a new suspension system, when he noticed the faded schematic I had carelessly left pinned to my bulletin board, a block diagram of my node's core architecture. He didn't say anything, just pointed. "What's that?" I froze. This was it. Exposure. "Oh, just an old concept, Sergeant. Something I was playing with. Didn't pan out." Reyes didn't take his eyes off the diagram. UWB ranging, magnetometer, altimeter, ad hoc mesh relay, relative positioning. He looked at me, his eyes sharp, missing nothing. "This ain't for a helmet, Doc. This is for finding your way out of the dark when the GPS fairies take a dump on you." My carefully constructed facade crumbled. He knew. He understood the problem, instantly, viscerally, in a way Peterson and Abernathy never could. It was just an idea," I stammered. "Got shot down. Too simple. Not mil-spec." Reyes let out a short, harsh laugh. "Mil-spec? Doc, downrange." "Mil-spec means maybe it'll last, sometimes probably expect crap. We don't need perfect. We need functional. We need now. You telling me this thing actually works?" That was the opening, the first crack of light in my bureaucratic prison. I hesitated. Trusting an NCO, even an SF-1, felt like a huge risk. But looking into his eyes, I saw not just understanding, but desperation. He needed this. His men needed this. I made a decision. "Yes, Sergeant," I said quietly. "It works." Or, "It did." I had a proof of concept. Over the next hour, hunched over my desk like conspirators, I explained everything. The shoebox, the beacons, the rejection, the hidden components, the software simulations. Reyes listened intently, interrupting only with sharp practical questions. "Battery life?" "Working on it. Aiming for 12 hours on the node, maybe 72 on the beacon. Weight? Targeting under a pound for the node, couple ounces for the beacon. Range through concrete? Simulations suggest maybe 30-50 meters, depending on rebar, but the mesh extends it. Data rate? Low, kilobits. Enough for text, coordinates, maybe biometric pings, not voice. Can it be jammed?" "Anything can be jammed, but finding this signal is like finding one specific grain of sand on a beach." When I finished, Reyes was silent for a long time, just staring at the schematic. "Okay, Doc," he finally said. "Here's the deal. Officially, I never saw this. Officially, you're still working on brain buckets, but I got guys. Guys who go places Peterson can't even find on a map. Guys who would kill for something like this, even if it's held together with duct tape." He leaned in, his voice dropping to a whisper. "You get me 1 working node and 3 working beacons. Make 'em small enough to fit in a pocket. Make 'em run on AAs. I don't care how ugly they are. Just make 'em work. Can you do that?" It was an impossible request. Building one-off miniaturized hardware with no budget, no official parts, no machine shop access. It was insane. "Sergeant," I started. "The components, the power supplies, I don't have the resources." Reyes held up a hand. "You get me the list, Doc. What you need. Specific part numbers. No questions asked. Let me worry about the resources. Just get it done and keep your head down. If Abernathy finds out..." He didn't need to finish the sentence. Reyes became my lifeline, my invisible quartermaster. Lists were passed discreetly. Components appeared. High-density lithium batteries, surplused from a canceled program. Tiny, powerful microcontrollers, salvaged from damaged targeting pods. Custom-machined aluminum casings that mysteriously showed up from an off-base friend of Reyes's. My pole bunker became a real, albeit clandestine, R&D lab. I worked with a renewed, almost manic focus. This wasn't just theory anymore. This was for them. For Reyes's guys. I rebuilt the nodes, cramming my messy breadboard circuits onto tiny, custom PCBs, soldering components barely visible to the naked eye. I designed a simple 4-button interface, waterproofed the casings with epoxy, integrated a small, vibrating alert motor. The beacons were even smaller, simpler, just the UWB transceiver, a coin cell battery, and a tiny magnetic clasp, all potted in durable resin. They looked like futuristic pebbles. After 2 months of near sleepless nights, I had them. 1 functional node, barely larger than a deck of cards. 3 functional beacons, the size of my thumb. They networked, they ranged. They displayed a crude relative map on the node's tiny OLED screen. They could send short, encrypted text bursts. They were ugly. They were non-standard. They were probably still riddled with bugs. But they were real. I met Reyes off base, in a dark parking lot miles from Natick. I handed him the small Pelican case containing the devices, my heart pounding. This was it. My stupid prototype was going out into the wild. "No instructions, Doc?" Reyes asked, hefting the case. "It's intuitive," I said, hoping it was true. "Green button is power. Red sends a ping. Arrows navigate the map. Just keep the nodes within about 100 meters of each other, or a beacon, and be careful." Reyes just grinned, a flash of white teeth in the darkness. "Careful is my middle name, Doc." He clapped me on the shoulder. "You might just save some lives with this junk. Stay low. I'll be in touch." He got into his nondescript pickup truck and drove away, taking my entire secret, illegal project with him, heading towards a world I could only imagine. A world of shadows, tunnels, and men who desperately needed a way to find their way back.